Alrighty, Math 10C. So now we are on to part 2 of 2.1. So we learned all about last video how to use tan ratio, how to set it up, how to even find the angle. Okay, remember that hypotenuse cannot be adjacent. Always find your hypotenuse. How to label triangles. So we did a lot last video. So make sure you maybe even rewatch it at some point. Just to kind of refresh yourself. Another nice part about these videos is they can act as a study tool, right? If you just want to sort of like, maybe you've been studying all day and you just want somebody else to kind of talk you over things, you can rewatch this video, which is a great idea. Now let's go on to example 2 here. We're going to determine the angle of a triangle if the tan ratio of this triangle equals 0.44. Okay. So let's read that again. Determine the angle of a triangle if the tan ratio of this triangle equals 0.44. Okay, so we obviously have some triangle. Okay, and this is a really arbitrary question. Okay, we're given this, and it's really important to understand it's giving us the tan ratio. We're given this, that tan angle equals 0.44. It's wanting us to find just some angle for this triangle. Well, we are given the tan ratio. Remember, if we're given the tan ratio, if we want to find angle, we have to use inverse. So in this case, the angle would be tan inverse 0.44. And that's literally it, guys. This is just a question to test your knowledge of if you know what the tan ratio means. If you remember, in order to find a degree, you have to use inverse tan. So now we can plug this into our handy dandy calculator. If I can learn how to use this iPad, okay? So remember, how do I get to tan inverse? We can't just simply put tan 0.44. That's going to give us a wrong solution. Okay, it gives us a number, but it's a totally wrong number. We're using the wrong operation. Remember, tan inverse is found in your tan button, but it is the yellow part. So in order to get to the yellow lettering, we have to press the yellow button and press tan inverse, and now press 0.44. I got to 0.44. So this one, let's round to the nearest tenth. Let's actually round it to the 100th here. So we got 23.749, but I want to round it to the 100th, which is this, okay? So I'm going to give it 23.75 degrees. And that is using our tan ratio in order to solve our angle there. Okay, on to angle of depression versus elevation or inclination. So these are two words that you have to understand. Angle of depression or angle of elevation. Another way to say it is inclination, okay? You have to know how to imagine these, okay? So your angle of depression, unfortunately the word depression we think of being down, right? It's kind of a sad way to think about things, but depression does mean to feel down, okay? And that's putting it in a really, really lighthearted way. Obviously, it's much worse than that. Anyways, this is going in a weird direction. Just think depression down, okay? Now, whenever you're talking about the angle of depression or the angle of elevation, you're either going up or you're going down, okay? And it's always to a horizontal. So what is a horizontal? Okay, a horizontal is exactly what it sounds like. It's a perfectly straight line, but straight across. So a perfectly straight line across horizontally. Okay, and remember, horizontally means from side to side. Okay. So if we choose a line that's from side to side, so we can see that line CD here is a horizontal. And if we wanted to talk about the angle of elevation, think of elevation as going up. Another way is inclination. The angle of inclination here would be the line from the horizontal up to the nearest line. Okay, depression here, angle of depression would be from the horizontal, so A to B is the horizontal in this case, and the angle of depression would be the angle that's created going down. Okay, so let's use an example. So you can copy this down quickly, pause the video. So determine the angle of elevation for the following triangle. So we want to use the angle of elevation. So this is our question, or this is our value in question. Okay, this is our question mark. Now, remember, always note where your hypotenuse is. My hypotenuse is over here. Okay, so this would be the hypotenuse of my triangle. Now, once we get into later chapters, you have to decide whether to use SO, CA, or TOA. Now, always ask yourself, in the perspective of my angle, what do I have? In the perspective of my angle here, I have this side length and 12. Well, in the perspective of my angle, number 1 would be opposite to that angle, and 12 would be adjacent. Now, that's why it's important to always represent your hypotenuse, because hypotenuse cannot be adjacent, okay? So if we look here, this tan angle equals opposite over adjacent, like it always does. But in this case, if we're talking about it in terms of this angle, it would be 1 over 12, okay? Now, this is the tan ratio. If you plug this into your calculator, you're finding tan ratio, which is sometimes we have to find. But in this case, this question's actually asking us to find the angle of elevation, which in this case is here. We have our horizontal, and it's increasing for that angle. So in order to find this, we need to use inverse tan. So inverse tan of 1 over 12. And if we grab our calculator, okay, remember, to get to inverse, we have to press the yellow button and press tan negative 1. 1 divided by 12. I'm going to bracket everything off. And that's going to give me 4.76. And I'm going to round to the 100th degrees. 4.76 degrees there. Okay, so there is our example 3. So we found the angle of elevation. Let's move on to example 4 here. So this is going to be a really quick video. Pretty much just practice problems, but that first one was a long video, so lucky you guys. So example 4 is an isosceles triangle, PQR. PQ equals QR. So the lines P to Q and Q to R. So recognize that we're not talking about a right triangle, we're talking about an isosceles triangle. An isosceles triangle simply means a triangle with 2 side lengths that are the same. In this case, PQ and QR. Determine the measures of the angles of the triangle to the nearest tenth of a degree. So this is a bit more of a challenging question. Anytime you're dealt with a challenging question, you need to do some things. Rewrite important info. So for you folks that maybe struggle with math, or anybody who's just getting into difficult questions, usually the first problem is we just look for numbers and formulas. That's not what math is. Math is problem solving. So I'm literally going to rewrite important information. So first off, this is an isosceles triangle. I'm just going to represent it like that. I know that PQ equals the line QR, which is 4.0 centimeters. And then I also know, so I know every single side length here and PR. What are we trying to find? We're trying to find all angles is our question. So now we have represented this big long sentence into just a few notes, okay? Now I'm gonna represent it as a diagram. Math, you pretty much always wanna represent as a diagram. So in an isosceles triangle, we have 2 equal lengths. So I'm gonna try and roughly draw 2 equal lengths. Remember, there's no 90 degrees in this triangle because it's an isosceles triangle. And then here. So this, I made this side length and this side length roughly equal. So that means you need to know how to represent this. So Q is the common vertex between them, and I can make this P and this R, okay? Why did I know to put Q on the top? Because if you change it, it totally changes what's happening. I knew to put Q on the top because these two have common vertexes. Another way to do it is draw a triangle first. P, Q, R. Okay, so obviously I changed it a little bit. And then note, this is probably what you guys would do. So P to Q is 4 centimeters and Q to R. So recognize that this is Q to R and you might read this as RQ. It's the same thing. Okay, it's the same lines. So QR or RQ is 4 centimeters and this is 6 centimeters. If you did this, this would work as well. Okay, so just recognize that. I'll just put this to the side here if you want to just note. So note, note this would work. Your solution might just look a little different because you have different angles going on here. Now, it wants us to find every single angle. So the question here is angle Q, angle P, and angle R. Okay, angle Q, angle P, angle R. So what are all these things? Now remember, SOHCAHTOA only works for right triangles. So you cannot just start using SOHCAHTOA here because you have no right angle. So we might have to make some triangles in here in order to use SOHCAHTOA. So I'm going to draw PR and put in 6 centimeters just to remind myself. How could I make a right angle? Well, you could make a right angle by simply dropping a line down to the horizontal. And then you have made it so there's a right angle here and a right angle here. Okay. And now we're dealing with a right triangle. You just have to know your side lengths. So something that's very good to do and get used to is I have now made a new intersection point. So I'm going to represent this intersection point as Z. Okay. So Z. Now I actually have 3 triangles going on here, okay? I have triangles Q to Z to R, right? There's a triangle here, here, and here, okay? Or I have Q to Z to P. So there's another right triangle. So I'm gonna draw one of these triangles out. I'm gonna kind of take it out. So I'm gonna draw a triangle, QZR, okay? So in this case, if we draw this triangle, QZR, now I have a right triangle to deal with, okay, which is super nice. I have a few of these side lengths. I have Q to R. I have 4 centimeters here. Now, Z to R, do I have that? Well, remember, I dropped this right down the middle. So this side, which I'm going to put // equals this side. Whenever you do that, you're showing that from P to Z, P to Z equals Z to R. Okay, so I now have those values that are equal. So I could have also done this using that notation. I could have put one line here and one line here. Now that simply shows that Q to R is equal Q to P. Okay, so some ways to show these things. Now, since P to Z, since this line segment equals this line segment, that means both those line segments are just half of 6. Okay, so Z to R simply equals 6 divided by 2. So to find z to r, we're going to do 6 centimeters and divide that by 2. So this is 3.0 centimeters. Now we can find one of our angles. Okay, we can find angle R. Okay, so let's find angle R. Now, how can we find angle R? Well, right now we only know how to use tan. Okay, so if we want to use tan ratio, remember TOA, opposite over adjacent. Okay, and remember I don't memorize that, I just memorize TOA, SOHCAHTOA. TOA. Tan equals opposite over adjacent. Now, in this case, let's look at what the opposite side length is. Now, remember, always find what your hypotenuse is immediately. This is your hypotenuse. Let's label that right off the dot. So the opposite side length from angle R is Q to Z. So I'm going to write that. So tan in the perspective of R equals Q to Z. And your adjacent side length, remember, it cannot be hypotenuse, so the beside side length would have to be 3 centimeters. So this will be Z to R. Okay. Now, we don't have Q to Z, but remember, we can use Pythagoras. So let's now find Q to Z. So remember, a squared plus b squared equals c squared. The biggest important thing with this formula is c has to be hypotenuse. So in this case, it would be 4 centimeters squared. Remember, as soon as you find your hypotenuse, a and b are kind of interchangeable. So I'm going to make a QZ. So I'm just making a this side length. So I'm going to write Q to Z there. So QZ squared plus B squared, which in this case I have, it's 3 centimeters, which is one of the other legs. So 3 squared. Now QZ squared plus, remember how to find the square button in your calculator. It is found right there. Okay, so if we want to plug that in, it will be 3 squared, which equals 9, and then 4, and then press my square button, 16. Okay, and now I can start solving for my, Now I can start solving for my QZ. So I'm going to subtract both sides by 9. So QZ squared equals 16 minus 9 will give me 7. And now I can square root 7. So square root both sides. Never forget to square root. Everybody always does. So QZ equals the square root of 7. Now remember, how do I get there? Well, your square root button is the yellow version of x squared. So press the yellow button, press x squared. So it gets you to the yellow part. And then press squared. And that's going to give me 2.6457513. So remember, I'm not going to round it by I'm going to try and keep a lot of decimal places. I only round once you're dealing with your final solution. So this will be 2.645751311. Okay. Now, let's put that away. We have Q to Z. It's that big, ugly, long number now. So let's write that up here. 2.6464575. That's about it. That's probably enough decimal places. Okay. Now we can solve for R. Okay, we have QZ, which is the opposite of angle R, and we have ZR. So let's plug those in. So now we could find the ratio if we wanted to. It's 2.64575. So it's our QZ, which is this, dividing ZR. ZR in this case is 3 centimeters. So 3 centimeters. This is the ratio, okay? If we want to find the actual angle, which is what we're trying to do, we have to use the inverse. So we have to go tan -1, 2.64575 divided by 3. Okay, and I'll section this off here. So that's going to equal, well, let's see here. So second tan, remember, because we're trying to get to the inverse of tan, 2.64575 dividing 3. That will give me 41.4096. Now, what does this want us to round it to? It wants us to round it to the nearest tenth of a degree, so that's 1 decimal place. So I'm going to round this to 41.9 degrees, which is angle R. So there's one of my angles. Awesome. Which is great. Now, let's go back here and show that. So this was angle R. We have found that to be 41.9 degrees. Now you could do that all over again to find angle P, but if you're really good with triangles, something you can understand is isosceles triangles have the same angles that are attached to the same side lengths. So there's this side length, that means that these two angles have to be the same, okay? And that's only in isosceles triangles. So that means angle R equals angle P. So that means this one's 41.9 degrees, okay? So we have two of 3 angles. Now we have to find angle Q. Now this is super important. Triangles, any triangle, all angles add up to 360 degrees. Okay, sorry, 180 degrees. Hang on, kind of having a little bit of a brain fart. Add up to 180. Whoops, that's my bad. So make sure you don't write 360. All triangles, any triangle, all the angles add up to 180 degrees. So in this case, angle P plus angle R plus angle Q should equal 180 degrees. So let's find angle Q. So angle Q, oh my goodness, let's rewrite that. Angle Q. Okay, so remember, we're going to use that fact. We know that angle P, I keep writing Q every time I want to write angle P plus angle, oh my gosh, angle R plus angle Q equals 180 degrees. That's something that always happens in triangles. Now we can plug all these values in. But we know that angle P equals 49 degrees, and we also know that angle P equals 49 degrees. So we could plug those values in here. So angle P and angle R both equal 41.9 degrees plus 41.9 degrees plus angle Q equals 180. And now we can simply solve for this. So 41.9 plus 41.9, let's figure out what that is. So 41.9 plus 41.9. So that's 83.8 degrees plus angle Q equals 180. And then we can subtract this. So subtract 83.8, subtract 83.8. And we're going to get angle Q equaling 180 minus 83.8. And that gives me 96.2 degrees. So we have found every single solution. Now, if I were to be nice, I would write all this down. I would write angle P equals angle R, because it's an isosceles triangle, and that equals 41.9 degrees. Angle Q equals 96.2 degrees. Okay, let's just check my solution here. Awesome. And then you are done. So remember, recap. This is a hard question. We had to make another line to create two triangles. We had to divide by 2 to solve for a length. And then we could solve for our angles. We had to know rules of isosceles triangles. But remember, if you didn't remember that, you could have technically solved for P by creating this triangle, but it would be the exact same thing you just did to find angle R, okay? Now, you should be ready to now attempt AFL 2.1. This is a pretty difficult chapter, so please be asking questions. If you are being confused or you don't know what's going on, take these notes, rewatch them. Okay, remember, this is 10% of your grade just to come in and show me that you did in fact watch the video and you took your time to take the notes. Come in, show me what's confusing you, and then we can work through AFL